With the title OPC UA for weighing, I would like to welcome Mr. Eugen Schiepli to the VDMA Shopfloor data sessions. Mr. Schiepli is the chairman of the core working group of the weighing technology and works in his normal life for Metla Toledo as market manager for Industry 4.0 in Switzerland. So now, Eugen, I would like to hand over to you.
Thank you, Mark. Can you hear me?
Yes.
Yes. So we just had a nice experience what it is or how important reliable communication is. I had to restart my computer and I didn't receive the phone call from Microsoft yet, in which I had to where they double check my identity. I hope this doesn't come up yet and I won't be interrupted one more time. Okay, as Mark said, I'm the chairman of the core working group for OPC UA weighing. I'm not only my activities within the OPC UA community is not limited to the companion specification weighing. In the past 5 years, I was a member of several work groups, such as the companion specification machinery. And I also look now and then into the work of other work groups, because my concern is that we do double definitions of the same functionalities, that different work groups having similar technologies, or that industrial work groups creating a companion specification for a certain industry, that they define nodes and methods for weighing as well, and that the user has a confusion. Okay, so I will first introduce you briefly to weighing. Then I will show something about the history of weighing, overlaps with other companion specifications, and particularities of the companion specification weighing, and at the end, recommendations for client selection, because our experience is that customers who have problems, they often have unsuitable clients, so it's not on the server side. And the presentation I'm going to do now addresses users of services, of servers, of OPC UA servers. So the scope of my presentation is not to provide information for equipment manufacturers that program their own server. So it is for users of servers using a client. Okay, so first a brief introduction to the weighing technology. There is on the left-hand side here, you see electromagnetic force restoration load cell. This is actually the highest resolution load cells. It can measure 5 grams down to a millionth or tenths of a millionth of a gram, and it goes up to 3,000 kilograms to a readability of 100 grams. And it is possible to have legal for trade resolution according to the standard here, the EN 45,501 of 500,000 E, or digits or increments, however you're used to say. In the middle and on the right-hand side, you see another technology based on the strain gauge. This is a single point load cell. This is a canister load cells for heavy loads, 4 to up to 1,000 tons. Here it is between 500 grams and 10 tons, 10,000 kilograms. Unlike here, where we have 500,000 legal for trade resolution points, we have a maximum of 10,000 for both of these load cell technologies that relate on strain gauge. The companion specification for weighing includes 140 pages. And it includes about 150 nodes, methods, events, and alarms. So it's quite a broad standard, because weighing is used in many different industries and for many different applications. Here I give you an overview of what is covered here. So simple bench scales, which are also used for automatic recipe weighing. So we have functionalities to send recipes down to the scale or to the balance. which the balance or the scale then automatically executes until it is completed, and it reports successful completion back to the client. We also cover piece counting. Weighing is an excellent method for counting screws and bolts and money, whatever you need. Then check weighing scales, conveyor scales. Here we have laboratory balances. There is you notice I'm talking about scales and balances. So typically for laboratory environment, we used to say balances, and in production environment, we used to say scale. So then we have here the filling control scale that can automatically fill a drum or an IBC or a big bag with data that were downloaded via OPC UA to the weighing equipment. Vehicle scales here up to 80 tons here with a multitude of load cells. Tank and silo weighing, dispensing out from silos or tanks, and also for inventory control. This is an application here where you have 10 grams per minute. As you can see here, this is a loss in weight feeder for continuous manufacturing processes. So here you have the full overview of the different scale types for the dedicated weighing applications. So the most common is simple weighing. Simple weighing includes gross, net, tare, and a couple of notes and methods that are coming from the companion specification machinery. Then we have, as I mentioned, piece counting, continuous weighing, catch weighers, loss in weight feeders. But all these scale types, they are based on the companion specification machinery. And I wouldn't say 100% of all scales fulfill the simple weighing scale type. I can really imagine that a lot of scale does not support the simple weighing, but probably 95% to even 99% of all scales and balances, they include the simple weighing. So what is typical, that is a scale or a balance supports simple weighing plus one of these other scale types, such as automatic filling or weight price labeling, check weighing, laboratory balances, and so on. Okay, now the history of this core working group is currently there are 6 member companies left, which defined this standard in close cooperation with the VDMA and the OPC Foundation. Another 6 members left the work group after we achieved about 95% of the standard. After we had release number 1.1, which is not on that list, so they left about in 2022. We had the first release in June 2020, and now just this month we released the version 2.0. But hey, actually, since version 1.0, not much changed, and we only have one little breaking change that probably doesn't matter for anybody. We also have a compliance test tool available, so you can have your server tested if it complies with the companion specification for weighing. That you are certain that it fulfills all the functionalities. Okay, I jumped, yes. So I mentioned that I will talk about the overlaps with the companion specification machinery. Why do we have an overlap at all? Why do we have serial number, software version, hardware version, and so on in our standard? This was because the companion specification weighing was completed before the companion specification machinery was available. However, we have had close relation with the work group for machinery, and we knew what they were doing. But to release our companion specification as fast as possible, we took these elements into our standard. So it's not a problem at all because we have absolutely the same definitions for the serial number, software version, manufacturer, and some other nodes from the machinery. Good. So important to know is that the companion specification weighing, it does not have its own state machine. In our first version, we referred to the state machine of PackML because weighing is very often used also in packaging environment for food, chemical, and pharmaceutical industry. And we didn't want to create our own state machine in order to make it easier for the users. Then in the last version, in the version 2.0, when we were close to completing this, the companion specification machinery completed their state machine. And we, in our standard, reference now to two state machines, to the PackML and the companion specification machinery. So if you are a user, if you use state machine PackML in the context with weighing, you're on the safe side. There is no breaking change. So we did not change from one state machine to the other. Both are still possible. And these are the pictures here. I copy-pasted them from the companion specification machinery from this presentation that was done in, I think about 2 weeks ago already. I do not intend to explain the state machine itself. I think here that this is the simplest version here. It's quite self-explaining. Important is for me to tell you that the state machine, that we have two state machines and that we do not have an own state machine, and that it is not a mandatory functionality for companion specification weighing. So you have to ask the vendor of the equipment which has a server if he supports, if he provides state machine data. Now we come to the particularities of weighing, of the companion specification weighing. We have created a node called current weight. And this is quite uncommon in OPC UA standard. We transfer 3 values at once. It is the gross value, the net weight, and the tare weight. Why do we do this? This is because most of you will know, but the gross weight is the sum of the tare weight and the net weight. And we all know also in information technology, these values, even at very high speed, they are captured one after the other. And so it can happen that you capture that the weight value has changed after the capturing of the gross weight, and then the net and the tare weight do not have the same result as the gross weight. And so the weighing equipment manufacturer ensures that this value is always correct. So if you use the current weight node, you are sure that gross is always tare plus net weight. And you also avoid rounding errors coming from from weight capturing. But why we noticed over time that not all clients support functionalities such as current weight, which transfers several values in one node. As a result, we introduced also the individual values, a gross node, a net node, and a tare node as individual nodes in addition to current weight node. But if you really need all three values at once, here it can happen that you will find a rounding error, or yes, that you find a rounding error. So now if you use a demo client such as we have here from, you can see here with the logo as from Unified Automation, if you test the equipment with the server, with the test client, you will find the node current weight and you don't see value. So you have to make, with your right mouse, you have to click to that value, and then this window here opens with these values. So here we had the perfect 0 point. But this is what you have to know. And if you evaluate a client and if you need current weight, just check with this provider if they support this functionality. Okay, another particularity is the so-called registered weight method. This method captures a stable weight and stores it until you trigger it again. So on this chart here, you see the brown curve. This is the actual weight value here as it is. And hey, unless you have the perfect environment, and if you're weighing, it is very common. It's not always, but it can be very common that you have always a little bit the fluctuating weight value, or that you place the weight onto the scale, then you trigger the register weight function and you take off the weight and the scale goes to 0. But if you capture that value with the registered weight, it is stored and it can be used for process control and for inventory control, even if the result, if the weight on the scale itself has already changed. So it can really be helpful in a workflow or in a continuous weighing process, that you have this functionality. It's actually a method that can be initiated by the client as well as with a keystroke from the operator on the scale side itself. So it has two possibilities to trigger the register weight functionality, either via client or by the operator with a key pressing, so on the human machine interface. It's a very helpful functionality. Okay, so important to know is here, we have the most common methods here. This is set tare, this is set pre-tare, if you know the numeric value. If you don't capture the tare weight by placing it on top of the scale and then initiating the set tare method, then we have the clear tare, and the set 0 method and the register weight method that I explained before. So what you have to know is it can take a while until you get the result from the method. And this is not because the server is wrong or because the method, the client is wrong. It can be that the scale is in an unstable environment, or that still some material is being filled into the container on top of the scale. And a tare weight can only be captured when the weight value is stable. And if you're in an unstable environment, it can take from 1 second, 2 seconds, up in an extreme case, maybe to 20 seconds until the weight at the scale can really capture a stable weight, and then execute the method and provide the result of the method. Important to know is again here what I write. Simple weighing scale type doesn't have mandatory methods. So the simple weighing scale type, we also, the work group had in mind that we want to make OPC UA also available for very simple weighing devices, which maybe cannot don't have the processor and the memory capacity to host a server that can execute methods. We want really to provide a simple solution also to make OPC UA feasible for inexpensive weighing equipment. And this is the background why we have not made any methods mandatory for the simple weighing scale type. Okay, so if you have successfully selected the right scale or the right balance, you have to select a client if you do not have a client already. And then if you talk with the guys from the client side, ask them the question, you know, that they offer the capabilities read client facet, you know, that they attribute client and read complex, attribute client read with proper encoding. Because we noticed that some clients are not able to perform these functionalities, and this happens very often when customers do their own client. By using any kind of free software modules and doing the client themselves, either because they have the ambition to do so or because they want to save money for buying a client. This is quite a common error that at the end we find out it's the error that the error is on the client side and less often on, actually never, at least for us, never on the server side. And also, again, here the current weight, ask them, show them the current weight functionality and ask them if their client can perform that. The companion specification weighing, I repeat, it provides gross, net, and tare also as individual nodes so that you can get the weight values without current weight. You have then the small risk of having rounding errors or an error because of they are not captured at the same time. Also check if they can handle the engineering units. Otherwise, you just get a code, a numeric code, and you have to encode this in your software then and allocate the right weighing unit to this number code. It provides a little bit more comfort. It's not impossible, you know, to use if you just get a code, a numeric code from the engineering unit, but it is a higher comfort level if your client can manage that and get right from the beginning the right unit. And this list here, don't worry, I'm not going to explain that. This again helps you because I assume you all download the presentation. And in case you evaluate the client for a certain scale type, on this overview, you find what kind of functionality that the client should support for the particular scale type. So for piece counting, recipe weighing, recipe management, totalizing, hopper scale, and so on. You need here these functionalities in this cross chart. You need these functionalities on the client side to really profit from all the functionalities of a server. That complies with the companion specification. Okay, so what is not part of the companion specification for weighing? It is legal for trade functionalities, everything around legal for trade, alibi memory, and so on is not part of the companion specification for weighing because the legislation in Europe is the same, but the implementation is different from country to country. And the work group decided not to negotiate with, I think, how many countries do we have in the European Union? I think it's about 28 countries or so. I'm sorry, I'm Swiss. I do not have to know that so precisely, but the work group decided not to negotiate and push that through with all these different national bodies which occupy legal for trade affairs. The companion specification weighing does nicer cover retail weighing applications because retail scales are usually bought by large supermarkets. They have the highest sophisticated applications and process control, and the huge supermarket companies, they usually have their own communication technologies, and they have different requirements than we have in industry, in manufacturing, and in research. So the work group decided to not working out a scale type for retail weighing.